Hello friends, welcome back. In previous video, we have seen the synthesis of R and S epichlorohydrin by using the chiral precursor or a starting material like the D-mannose and also the glyceraldehyde molecule. So our next target molecule is L plus alanine. So the structure for the L plus alanine is like this. This is the amino acid and this amino acid is very reactive. Therefore, it is kept in the protected form in presence of the acetic anhydride. Means what? This is a very reactive. Therefore, if we keep this molecule in the acetic anhydride, then here we have a lone pair over this nitrogen atom and the acetic anhydride is the electrophilic center. Therefore, this NH2 can be protected and we got the molecule is the N-acetyl L-alanine. So, this is the N-acetyl L-alanine. So, what are the L and D configuration? So, here the L and D represents the relative configuration and it is the generally used in the carbohydrate and alpha amino acid. So here this is the L amino acid because this NH2 in this left hand side, therefore this is the L alanine and the plus indicate as a dextrorotatory. Therefore here this structure it shows the L plus alanine and this is the N acetyl L plus alanine. So due to this highly reactivity, this is the stable form or a protected form of this L plus alanine and this is called the N acetyl L plus alanine. So all the amino acid except the glycine, there are the 20 amino acids. So the 19 amino acids are naturally occurring in the L configuration and their absolute configuration is S configuration. So here we have a L plus alanine. We have to synthesize this target molecule. So why there is a need to synthesize? Because these are used in the medicinal chemistry. Therefore, there is a need to synthesize of this target molecule. And to synthesize, before synthesis, we have to study what is the retrosynthesis for this L plus alanine molecule. So what do you mean by the retrosynthesis? It is the imaginary but the logical reverse reaction which helps us to get the possible starting material. This is called the retrosynthesis. So see the retrosynthesis. So here the another classical demonstration of use of carbohydrates by maintaining the absolute conformation natural product is observed in synthesis of N-acetyl L-alanine which can be synthesized from 2-amino 2-deoxy-D-glucose. Means what? This is another target molecule which we have to synthesize. What is the target molecule is L-alanine, but it can be protected by using the acetic anhydride and we got the N-acetyl L-alanine. So our target molecule is N-acetyl L-alanine and which can be synthesized from the 2-amino 2-deoxy-D-glucose. So this 2-amino 2-deoxy-D-glucose is our starting material. So see the retrosynthesis. Here we have our target molecule N-acetyl L-alanine. This is the disconnection arrow and over we write here the functional group interconversion. So this can be converted into this. Then again here this NHAC is deprotected or can be this AC is converted into this NH2 and here there is a aldehydic group. And in last step we got the 2-amino 2-deoxy-D-glucose. This is the structure for D-glucose but here there is a no hydroxy group. Here it is a NH2. Therefore we write here 2-amino 2-deoxy-D-glucose. So this is our chiral precursor for the synthesis of L plus alanine. So this is the retrosynthesis for N-acetyl L-alanine. See the synthesis. So this is our starting material, that is 2-amino 2-deoxy B glucose, and these are the reagents to make our desired product. So see the mechanism. First here the starting material 2-amino 2-deoxy D glucose. So in first step there is a acetic anhydride in presence of MOH and base. So here there is a this NH2 group, and we know here it is a lone pair over this nitrogen, and it can be attacked over this Ac2O, means acetic anhydride, and we know the structure for the acetic anhydride. Here it is a carbonyl group. This nitrogen, lone pair of nitrogen can attack over this, and we got here it is a NHAC. Okay, in next step there is a here we convert this molecule into the aldehydic group. Here you can say this converted into this aldehydic group. Then after here we write the excess of ETSH. ETSH means this is the ethyl thiol, like the diol molecule or a alcohol. Here it is a thiol, and in this structure the carbonyl group is electron deficient, and here the lone pair over this sulfur atom can easily attack over this, and here there is a opening of this bond into oxygen. We got the O negative, and this negative can abstract this proton. There is a formation of OH molecule. Then after again this OH molecule is converted into H2O for the removal or to form the good living group. This OH is converted into H2O, means in first step this lone pair can attack over this carbon, and there is a formation of OH. Okay, in next step again abstract this proton, and there is a formation of H2O molecule, that is it become a good living group, water molecule. Then after the second molecule of ETSH can attack over this, and there is a removal of water molecule, and after the removal of water molecule we get this type of glucose structure. Okay, so here there is a removal of H2O, and excess means 2 moles of ethyl thiol is used. Therefore here we write the 2 times SET, and it can be write like this. Here it is the first carbon atom, there is a one hydrogen. Okay, so this is the one hydrogen, this first carbon atom, which contain 2 molecules of this ACT. Okay, and remain structure is as it is. So in next step there is a reagent ranitidine. So ranitidine is used for the reduction, and we got here the CH3. This ACT and ACT can be replaced, and we got this CH3. Then there is a cleavage of this carbon-carbon bond, and after the cleavage of this carbon-carbon bond we got this structure, this along with the glyceraldehyde. Means if we break, here it is the first CH3, okay, then this second carbon atom containing this NHAC, and if we break from this, then there is a formation of, there is a aldehydic group. This carbon is this carbon CHO, and here the next or byproduct is a glyceraldehyde molecule after the breaking of this carbon-carbon bond. Okay, so for the cleavage of this bond we use the lead tetraacetate, and after the formation of this product we use the Br2 in presence of H2O, that is the aqueous medium, and this is the mild oxidizing reagent. It can be converted this aldehyde into an acid. Therefore this aldehyde converted into this acid group. Okay, and this can be write like this. So this is the target molecule, that is the N-acetyl L plus alanine. And after the hydrolysis, we got here the NH2 group. See again the mechanism. This is the retrosynthesis, and we got our starting material, that is the 2-amino 2-deoxy D-glucose. Okay, so our L-alanine structure, in this L-alanine there is a NH2 group, but this is the highly reactive, therefore it can be protected, and we got the N-acetyl L-alanine. And see the retrosynthesis, after the doing retrosynthesis we got 2-amino 2-deoxy D-glucose. Okay, so in second carbon there is a no hydroxy group, here it is a NH2 group, therefore here we write the 2-amino 2-deoxy D-glucose. This is our starting material. So see the synthesis. These are the reagents. Let's see one by one. In first step, this 2-amino 2-deoxy D-glucose is reacted with acetic anhydride in presence of methanol. So this NH2 is protected by means of this N-acetyl group. Then after this OH can be converted into this aldehydic group. So after the formation of this aldehyde, these 2 moles of ethyl thiol can be react with this carbonyl carbon, and there is a removal of H2O molecule. We got this product. Okay, so after the formation of this, here we can write like this structure. Then after we use the ranitidine to convert this into this CH3 group. After the formation of this CH3, there is a cleavage of this diol by using the lead tetraacetate. So after breaking of this, we got a 2 molecule. This is the first one, and next one is a this below group, that is the glyceraldehyde. Then this aldehyde can be converted into this acid by using the mild reducing reagent, that is the Br2 in presence of water. This aldehyde is converted into this acid group. So this is our target molecule NHAC. We can write here like this. This is the N-acetyl L-alanine, and after the hydrolysis we got this deprotected form, that is here NH2. This is the L plus alanine. So here the final product is N-acetyl L-alanine. This is our target molecule. I hope you understand. Thank you for watching.